In the previous example, where Mr. Kwan was going to Kim Kardashian's baby shower, we basically used this formula that we're about to talk about, which involves the average rate of change. So the average rate of change of a function y equals f of x from x equals a to x equals b is defined by this formula. Average rate of change is equal to f of b minus f of a over b minus a. And again, this is basically the slope formula, y2 minus y1 over x2 minus x1. What that looks like graphically is, here's my y-axis, here's my x-axis, and if you have some kind of function that looks like that, and you have an x value here at a, and you have an x value here at b, the average rate of change is basically, you're looking at this ordered pair and this ordered pair, and if you drew a straight line that went through both of those ordered pairs, the average rate of change is, again, basically the slope of that line. And that line has a special name. It's called the secant line. So slope of the secant line is equal to the average rate of change. Example 1 says, Mr. Kwan opens up a stand to sell boba. If you don't know what boba is, boba are these tiny delicious Asian balls that are made from tapioca, and they'll make all of life's problems disappear only momentarily. The total cost in dollars to produce X units of boba drinks is modeled by the function c of x equals 300 plus 2x plus 0.05x squared. Find the average rate of change of total cost for the second 100 units produced. Another way of saying that is from when x equals 100 to x equals 200. So the average rate of change is equal to c of 200 minus c of 100 over 200 minus 100. So let's come off to the side here and evaluate c of 200. So that's going to be 300 plus 2 times 200 plus 0.05 times 200 squared, and that's going to equal 2,700. And then we also want to evaluate c of 100, so that would be 300 plus 2 times 100 plus 0.05 times 100 squared, and that ends up equaling 1,000. So if we simplified this, we get 2,700 minus 1,000 over 200 minus 100. And then if we simplify that, that's going to look like 1,700 over 100. And then that ends up equaling $17 per unit. So that means on average, when producing units between 100 and 200, the average cost is $17 per unit. Example 2 says, Mr. Kwan is leaving Red Lobster after having some of their delicious Cheddar Bay biscuits. He even has a to-go box of some of them. As he is leaving the restaurant, Mr. Kwan sees his trash X in the parking lot. One look of his X's face makes Mr. Kwan throw his entire to-go box of Cheddar Bay biscuits at his X. The height and feet of the biscuits after t seconds can be modeled by the function h of t equals negative 2t squared plus 12t plus 6. What is the initial height of the biscuits? So we would like to evaluate h of 0, because this represents 0 seconds, which is the initial time. And if we do that, we get negative 2 times 0 squared plus 12 times 0 plus 6. The first two terms become 0. And if we simplify that, we get 6. So the initial height of the biscuits is 6 feet. Part B says find the average velocity of the biscuits between t equals 1 and t equals 3 seconds. So average velocity is basically the average rate of change. So we want to calculate h of 3 minus h of 1 and divide that by 3 minus 1. So if we evaluate h of 3 off to the side here, h of 3 is equal to negative 2 times 3 squared plus 12 times 3 plus 6, and that is equal to negative 2 times 9 plus 36 plus 6, which equals negative 18 plus 42, and that ends up being 24. And then we also want to evaluate h of 1, so that's negative 2 times 1 squared plus 12 times 1 plus 6, which equals negative 2 plus 12 plus 6, which equals 16. So if we come back up here, that is going to be equal to 24 minus 16 over 3 minus 1, which equals 8 over 2, which is 4, and then the units, the numerator was feet, and then the denominator was seconds. So we have that the average velocity between 1 and 3 seconds is 4 feet per second.